begin all of our sessions, we're going to open up with a couple polls to help Kevin understand your experience with indexing and performance tuning and all those good things that we're going to talk about today. First question is, how do you presently determine performance problems with your SQL Server environment? Leave that up for a moment. Hopefully this can be interesting for you too. Kev, can you see the polls going through there, the progress?
Actually, no. I just see the question there. Oh, yeah. You know what? I can see that it's open now.
Oh, great.
Yeah, that's really great. I have not used this interface before, so that is really neat.
Give some good feedback to a pretty influential guy at Quest Software. He can make that new feature for you in the diagnostic tools. All right, we're just about 70% there voted, so I'll go ahead and close that out. Looks like Management Studio is the tool of choice for everybody here. I'll share that with everyone so you can see what it is we're looking at. Okay, and then I'll hide that, and I have one more question for you. I should say Kevin does. How would you rate your current SQL Server database performance? 1 through 5. Of course, 1 being poor and 5 being excellent. How would you rate your current performance? And Kevin, while that's going, I have to apologize for the multiple phone calls. You had me nervous.
No worries at all. And I apologize to you. Yeah, I had come in. I think I used the standard, attendee connection rather than the presenter connection.
Ah, I see. That might have messed me up. That's okay. All's well that ends well. All right, we're over 80% that have answered that question, so I'll close that out and share it with everybody. Looks like, it's kind of that typical bell curve there, right? We're looking at an average. People are thinking average to above average, which is good. Nobody's poor and not many are excellent. So hopefully Kevin can help you today with some of the tips he's going to share with you. I'll hide that poll. And Kevin, I'll make you presenter. I'll stay on with you until we can see your screen.
All righty. And again, not real familiar with the interface, so let's go straight into the PowerPoint presentation. Right?
Yeah, you go straight in. With GoToMeeting, you see everything on your desktop. You don't have to upload. So we can see your screen now. Nice Quest slide.
All right, and now I'm switching to just the standard slide deck. How does that look?
That looks fantastic. You can see it. Your audio is good. So I'll go on mute, and if anything comes up, I'll just interrupt you and let you know.
Yep. All right. So
all right.
I'm
Thanks.
Going to minimize the little screen sharing icons and that sort of stuff that come with the
oh yeah, just hit the orange arrow at the top left of the GUI there.
Control panel. Yeah, that's perfect.
That do it? Okay. All right. All you.
Okay, great. Thank you. Much appreciated. And folks, thanks so much for spending some time with me today. I know you've got a lot to do, and so I'm really thankful and grateful that you decided to spend some of that time with me. The slide deck has more slides than I think we have time for, so we just have an hour here, and I want to make sure that we get through all of this. So in some cases, I may actually go a little bit faster than we might want. A couple things to think about. A little bit about indexing will be outside the scope of what we're talking about today. So I'm not going to spend a lot of time talking about particular statements used to create or drop or alter indexes. I'm not going to spend a whole lot of time on special case indexes, things for full text search or image or text files, blobs, stuff like that. And I'm also not going to spend a whole lot of time on locking transactions and isolation levels, although that has a huge impact on how useful indexes are, and vice versa. Indexes can have a really big impact on locking and transactions and so forth. So the main thing we're going to focus on are, what's an index, what are the structures and the fundamentals, some of the strategies for choosing what is a good index, and then also, kind of implicit in the title here is index tuning strategies. So the idea is we can deploy indexes, and the way we write our queries is also really pertinent to how useful indexes are. So it's a strategic sort of decision, and it's something that we can think about in that kind of strategic, overarching sort of way. And if we don't have good indexes, we can change our queries to make the best of a bad situation in some cases.
Kevin, Could I while you're switching that slide, is there a chance you could dial in with I don't know if you're on the cell or the voice over IP right now.
I'm on the cell phone, yeah.
You're on the cell. Okay, it's coming in a little choppy.
Okay, let me do this. I'm going to turn off my Bluetooth, actually, and we'll see how that does.
Oh, yeah, that might do it. Sorry, everybody. I know you're interested in getting the cleanest audio possible.
Is it any better now, or am I two or three bars too low?
No. That's much better. Much better. I'll let you know if it goes south, but that sounds great.
Okay, yeah, perfect. Do ride trail off on that, and if I start dropping out or something, I'll go voice over IP.
Okay.
Okay. Yeah, great. Thanks. I appreciate that, Tim. And yeah, just jump in at any point. I've been doing this. If you don't know me, I've been doing this for a long time. And my first big computer system was a VAX. I worked on some PDPs and VAX DMSs back in the early late 80s. That 86 to 88. Did some work for NASA using Oracle back before it had a programming language. It used Fortran to do pre-compiling of Oracle code. And over the years, worked on really large-scale database systems. I was a president of the Professional Association for SQL Server, and served on the board of directors there for quite a while. I've been a SQL Server MVP. I've written a lot of books over the years. SQL in a Nutshell is my best-known book. And I do blog, and I blog frequently, kevinecline.com, as well as do Twitter. So if you keep up with Twitter at all, I encourage you to follow me, and I'll try and do the same for you. Now, there's a lot of words on this slide here, but the main thing to notice is that we're going to talk about how to pick your indexes, how to write your queries to take advantage of the indexes, and then for those of you who are new to the whole topic, we'll also look at what is an index, how does it work, and some important things about the physicality, the physicalness of indexes. So those are the big kind of bullet points as we go throughout this slide deck to think about. What is an index, and how does it work at a physical level? How do we choose good indexes, and then, so how do we choose good indexes, and then what do we do for our queries to make those queries work really well? Okay, so let me take that little guy out. And the basics to start with is that we have tables in SQL Server. Tables are where we store data. And within the storing of the data, we are able to do things to make that data faster and, it is more accessible. And the primary means of doing that is a index. The funny thing about indexes, though, is that all data is stored on these pages. So here we have the leaf pages. That's where the data is stored at the very lowest level. And they're 8K in size. And when you subtract out the overhead for the index allocation maps and the global allocation maps and the page header and page footer stuff, it's about 8064 bytes available for use as data. But then we also have our pages that are used for indexes, and those are also 8K. And so in a sense, when you think about an index that is created on top of the leaf level data at the very, the data that exists in the table, indexes are also tables in a sense, except that they contain pointers that get us to the data more quickly. So we have this root page, and that's the highest level of any indexing we might have if we've created a clustered index. The clustered index actually sorts the physical data as it's written onto disk. And so if we ask for this data in the clustered index, again, it starts at the top level of the index and does a lookup, finds the pointers that get us closest to it. So let's say we've got just a phone book that's our table, and so it goes to the top level where it's A through K, and then on the other side of that page is L through Z, and then it finds in this intermediate page more direct route, maybe just to the Ks, and then finally takes us directly to the data at the bottom level there. So those intermediate pages are pointers that get us to all the data that we might need at that lowest level. Now we compare, just to flip back again, we compare the clustered index. That's the physical order the data is arranged on the database, on the tables that is, without any kind of clustering. And that's called a heap. And basically a heap is like you're just pouring water into a glass. You don't actually specify where certain parts of that water go. You can't tell it, hey, I'm going to put all the light blue water over here and all the Kool-Aid that's dark red over there. It just all goes into the glass. And so a heap is a table without a clustered index. Now, it can have non-clustered indexes, but it would still be a heap, as long as it doesn't have that physical ordering that is provided by the clustered index. Also, all the records, as I mentioned, there's no ordering on those, and there's not a double linked list that comes with the ordering of the records in the clustered index. So why am I even talking about it if it doesn't have this stuff? Aren't they useless then in that case? Well, actually, no. Heaps actually do have some situations in which they can be really useful. The primary case where a heap is useful is when we need to load a lot of data in one big load process, and we're starting from zero. So we've got an empty table. Maybe we're going to create that table. For example, we've got an ETL server, and we're going to do some extract, transformation, and load of data. Maybe we've got a staging database somewhere, and we need to load 30 million records as quickly as we can. You're actually going to be better served to have a heap and just load all of that data directly, serially, one record after the other, as quickly as the system will go, and then create your indexes afterwards, including a clustered index. That will be faster than actually having a clustered index, maybe with some non-clustered indexes as well, and doing that same exact load. So I mentioned heaps because they do have their uses, and they are actually pretty good for certain use cases. However, as the last couple notes there point out, they can be inefficient for most forms of transaction processing, inserting, updating, deleting. Even reads can be very problematic, particularly because anytime you need to get, like, let's say, a range of values out of that table, if you don't have a clustered index, your range scans are probably going to wind up scanning the whole table. They can also, heaps can also cause something called forwarded records. What happens is SQL Server has to create a 8-byte row identifier for every record inserted into a heap. And let's say, for example, you alter, you do an update statement on one of these records, and now it is so large that it doesn't fit on the page. So what, after that alteration, what it does is it'll write the rest of the data elsewhere, and it has to use this row ID to kind of forward SQL Server onto the next part of the record to find that data. And so that can be an indication that you've got heaps set up in a way that are not very efficient and would benefit from a clustered index. There is, by the way, both a perfmon counter and some other things you can look for. You could set a perfmon counter to look for forwarded records in your SQL Server. So that'll let you know if you have heaps that would really benefit from having a clustered index applied to them. Now, another thing that happens in our SQL Server tables is something called page splits. What happens with in a situation like that is we have, for SQL Server, we have a situation where we have, whenever we create an index, or whether that's non-clustered or clustered, SQL Server will create every page in that index that's 100% full. So that means it's going to fill up each of these different pages as it goes along. And, so you run that insert operation, or maybe you create the table and do a select into, or, however you build that out. It will add all of those records in until each of those 8K data pages are full. And so that means there's no room left in each of these pages when you do additional inserts or updates or, well, not so much deletes, but typically with inserts or updates and inserting new data. So what happens to the SQL Server database when we need to, what happens when we need to insert a record and we need to insert it right in the middle of a table that, of a data page? Excuse my scribble there. But we need to insert that in, and it's full already. So we insert a record, and what happens in that situation is the record Let me actually, my screen is kind of messing up here. Oh, you know what? It looks like my animation went backwards. So let me go back here. We insert a record here, and what happens is, let's say these are intermediate index pages right here. So this is the leaf down here at the bottom. What SQL Server has to do is it has to split that data page apart. And so the record was going to be inserted right at this point. And all the other data that's in this page now has to be moved up to a new data page. And it's taking this 8K page of data and splitting it in half. And it's an extremely I/O intensive operation. So it has to insert all those, 1 or 2 or 5 extra records right here, and it has to move those over to new pages, possibly at the very end of the data file, to make room for that according to the clustered index. So this can really promote a lot of fragmentation, if you will, because the records had to stop here and then pick up and begin over here. And since that could be at the very end of the data file or something like that, now it's kind of broken up into chunks. So what you can do in order to prevent these page splits from happening is you can rebuild your indexes on occasion, and you can specify fill factor when you rebuild them. So, and there's a number of different commands you could use. You could use dbcc index rebuild or db reindex. You could use index defrag. I think you can also use, actually the preferable way to do it now would be to say alter index. And you can tell it with a fill factor of, let's say, 80%. A good rule of thumb for your transaction processing systems is 75, 80, maybe 85% full. So you'd say fill factor equals 75, and when it rebuilds the index, it will actually it will fill up each data page 85% full and leave it 15% free, which is really, really useful for these OLTP kind of heavy transaction processing systems. Now, also notice here that on the intermediate pages, I also show that page splits can happen on your intermediate pages too. And I've even had some systems, that were busy enough for that to happen. So when that does, you can actually just specify the pad index option. And what that does is when you rebuild the indexes for your SQL Server, it will push the fill factor values up into the index pages as well, so that they will have a little bit of free space in them in the future, going forward from that point forward. Now, you may have figured out by looking at that that's not always great, because it does, cause the indexes, the clustered index, the unclustered indexes, to get bigger. And so you do have more pages to read into memory and to do your work with. But typically, page splits are so costly that it's worth a little bit of extra reads or writes needed to maintain those extra data pages. So there, I've talked a little bit about what's going on in SQL Server indexes, with your your clustered indexes and page splits and so forth. So again, just think about clustered indexes. This is the order that the data is actually physically written on the disk. And your select statements are not going to retrieve. There's kind of a myth out there that if you create a clustered index, SQL Server will always return data in the order of the clustered index. That's not really true, but not really true since about 2005. So I don't want to propagate that myth that if you have a select statement without an order by, it will return it. It does. That's not actually true. It does not do that. These numbers here, you can have one clustered index per table, and of course that makes sense. That's the physical order it's written, so you can't write the physical order in lots of different ways. You can actually have a larger number of non-clustered indexes now in the more recent versions of SQL Server, and they are recommended for every table. It's really a good idea for you to have a clustered index on pretty much every table. There are situations where you might skip it. Let's say a table that is extremely small. Maybe you've got a lookup table that lists all 50 of the United States states. So, really maybe that takes up 1 or 2 8K data pages. That's tiny. Well, you probably don't need it there. But even so, it's not a bad idea at all to do that, particularly for database design reasons, because when you declare a clustered index, you can also primary key if you want to. You could make it your primary key, and so that might, just aid in the logical reading of the data in your database. It's especially helpful as well for group by and order by clauses, things like that. Now, non-clustered indexes are a little different. Non-clustered indexes are useful for finding a range of records or helping you zero in on a specific record. And although it uses a separate structure from the table itself, so clustered index is the table in its data. A non-clustered index is a separate structure. And anytime a change is made to the base table, like an insert or an update or delete, those changes have to be propagated through into the, not the changes themselves, but information about those changes need to be made in the indexes. Basically, the indexes are pointers. And so they're going to be a lot smaller and narrower than the actual original table. But if you do a lot of changes in the original table, you add a bunch of records, then, of course, all the pointers have to be updated in non-clustered indexes as well. And they can be very, very useful for speeding up your queries. Well, how do you choose which columns that we are going to use in either clustered indexes or non-clustered indexes? And there's a couple rules to follow when creating indexes. The first one is frequency of access. So if you look for data in your database frequently based on a particular column or a combination of columns, and it's something you could filter in some way. So in the example of something like a phone book, the simplest table of all, well, we look up things quite frequently by, let's say, the name of the business or the name of the person. That is going to be a great way because we either are looking for a specific value or a range of values to find. So that would be great for an index. For example, if we look for appliance repair, that would return a range of values. Whereas if we look for a specific person, either based on, say, their Social Security number or, when they were hired in the database, when that record was added, so then we could see, hey, anyone hired between those two particular dates, we can look them up and find them very quickly in the database. Another example is for foreign keys, and this is actually kind of tricky too because the default behavior for SQL Server when you create a primary key, and this is the default, you can override it, but when you create a primary key is that it's going to attempt to index it, and it's going to attempt to make it a clustered index actually. So you can change that around. You can say no index, you can say a non-clustered index. But you would think that it would do something like that whenever you declare a foreign key inside of a SQL Server schema. But no, it doesn't do that. And foreign keys are usually a beautiful opportunity to add index. Always good candidate. So in this case, this is a really old pubs database, but we have the titles table and then the sales table. And the titles, the p.title is the primary key of the titles table. But when it appears in the sales table, gosh, we're going to be looking up a lot of sales to see, how many of a particular book sold. So why don't we go ahead and index that so that it will speed up all of those different scans and turn them into seeks rather than scans. Let's see here. A couple other things to think about. The clustered index can help with sorting. So if you want to arrange the rows in an order that they're most commonly retrieved, the clustered index in particular can help with that. And another thing that's really, really useful inside of SQL Server is this concept, or actually it's for all relatable databases, Oracle, Teradata, DB2, MySQL, any of them. There's something called a covering index. So what happens there is, let's say, for example, we have a situation where we need to find out the number of hire dates that occur, distinct hire dates that occur in that employee database. If all we're going to look for are the hire date values, and that particular column, hire date, is indexed, then the index is said to cover that query. I got you covered. I got all the data you need right here, and we don't actually have to go down to the leaf level, that third level in the little diagram I had. We don't have to go down that far. We can get it from that second level. And as you saw a few slides ago, that is going to save you an enormous number of data page reads in the system. It's a really powerful way to speed up your processing. But you can also do that by intentionally including columns in different indexes and so forth. So, for example, if you always ask for a person's first name at the same time you ask for their last name in an employee database, well, why not go ahead and index employee last name, and then in that same index get the employee first name, and that way your index will answer any queries against those two columns, rather than having to go all the way down to the data page or the leaf nodes of the table. If you need to avoid duplicates, the best way in the world to do that is to declare either a unique constraint, a primary key constraint, or something like that, and to index those. That's going to make it faster and more effective if you've got a lot of distinct values. So, one thing that kind of amuses me is every now and then I'll see someone who has put a index on a column that describes an employee's gender, let's say. And honestly, how many distinct values are we going to have in a column that describes a person's gender? Hopefully not too many more than 2 or 3 different values possible for gender. I mean, it just doesn't have that many distinct values. So that would be an instance in which you wouldn't really need an index on that column. So if you're going to use a column in a where clause, a group by clause, any of those kinds of things that sort and organize the result set of a query, that is a good candidate, typically a good candidate for an index. Now, one question I get asked a lot is it better to have lots of columns, lots of indexes versus just a few indexes? And this question comes up out of the fact that every time you do inserts and updates and deletes to a table, you add records or change records or take them out, all of the index pointers have to be adjusted. So if you have a table that has 140 indexes on it, well, that means every time you insert a new record, 140 pointers that deal with the column that was just added have to be adjusted. So I hate to tell you this, but the answer is it depends. Typically, what it depends on is the nature of the application. If your application is really heavy on kind of randomized reads and writes, it's a transaction processing system, OLTP, then you're going to want to kind of to be cautious about adding lots of indexes. And I guess the rule of thumb is, can you try to keep it around 20 or less? Maybe you can't do that, maybe around 40. You don't want to have too many, so keep it to a handful or not too large a number of indexes. If, on the other hand, your application is if the application is, read heavy, it's a reporting application, it's a BI application, it's, used for a big data load process, and so we just read a bunch of records and do lots of selects and reports and stuff like that, then in that case, add as many as you want. The indexes are not going to do much harm at all to performance, and the overhead that they do have will not be noticed, since the vast majority of the work you do in that database is related to reading data and not changing it. Another question that gets asked a lot is, what about having lots of columns in an index? What's the trade-off there? Should I have an index with 16 columns, or should I have an index with no more than 2 or 3 columns? I think these numbers might be a little bit old for SQL Server 2008. I think you can actually go way beyond these numbers here. But the gist of it is that whenever you create a concatenated key, it typically is going to have more than one column. So we're going to have one column plus at least one other column. And there is, again, a little bit of overhead for having multiple keys to the index or to the constraint. I'm sorry, columns to the index or constraint. There's a little bit of overhead, pretty much just based on the amount of extra reads that have to be performed. So, if you're reading 16 megabytes of data as opposed to 32 megabytes of data because you've added another column, and then it's just a difference in the amount of I/O that needs to be done. But so it's really, I think it's a preferential question, kind of, and some people have these long religious wars over whether it's better to have a natural key, what they call a natural key, which might be, several columns together, versus a surrogate key, which, maybe we're going to provide a GUID rather than, combine these three columns together to get that unique value. So there are reasons why it may be more valuable to do one way versus the other. For example, if it's a smaller database, you might prefer to have a concatenated key because the key itself, when you look at that data, it makes sense. You can understand it when you see that there's a first name, a last name, and a hire date in that key, and you can actually look at that and gain information out of it right away by just looking at the data in that index. The flip side, though, is that just having a GUID or maybe an identity column or something like that, well, that's really fast. You don't have to read a lot of data. It's it's really narrow and tight and so forth. And so there are situations where one or the other might be better. Now, something I mentioned a little while ago, and I just covered it in passing, but I want to spend some more time on it, is this idea of a covering index. And now, a covering index is one that answers a query entirely through referencing the data of, oh, excuse me, I just sneezed there. A covering index is one that answers a query entirely by going to the intermediate pages of the pointer pages of the index, and it doesn't have to go to the leaf pages of the data itself. So here we're selecting the employee last name and the employee first name, where it's like Matlieb or Gottlieb or any variation of that. So all of the columns in this query, it looks like they are actually here in the employee name level index. So we see there's the last name, here's the first name, and we can get all of the data without actually having to do a a scan or anything like that, or read from the table. We can get this from the intermediate pages of the index, and it's much, much faster, really fast. This is not to be confused with a feature called included columns. So there is this capability in SQL Server to include columns in an index. So for example, the first name right here, we might include first name in a column and not index it. So that means that we don't adjust pointers or anything like that. It's merely used, that data is merely included right side by side with the last name. And so it's not actually set up as a means of looking up data. It's just provided there for you to speed up the retrieval of data. So that's a lot about indexes, talking about how to build a covering index, an included index. And just in passing, too, there's another kind of neat index you can use in SQL Server beside an included index of a filtered index. So you can actually, in a sense, even build in a where clause on an index within SQL Server. And that might be useful in a case in which maybe, you've got a column for employee that says active, whether the employee is active or not. And so maybe you're going to actually have a filtered index on the column where the bit for that flips whether they're active or inactive. And that way, when you retrieve data related to active people, it's already filtered out for you. And so it makes accessing that data a little, just that much faster. So this is some best practices tips for the query, for queries and how to help your SQL Server do better by the queries that you have in the system. And the first thing to remember is that the SQL Server Optimizer, it gets better with each release. So there's a few recommendations I have in here that are more applicable to older versions than they are newer versions. But in general, all of the things that I'm telling you are really, really useful for all the different versions of SQL Server. And in addition to that, there's some just kind of basic rules here about your queries. And the first and most basic rule of a query is that the more you can tell the query optimizer about what it is you're looking for, the more you can, the more information, I guess I could say, that you provide to the optimizer to quickly resolve that query. So if you can include different filter conditions, in the where clause, especially against indexed columns, that's going to help a lot. If you have built your indexes on columns that are frequently joined, that will help a lot. And then, again, if you can, take advantage of and make use of the covering indexes, that's going to help a lot. The key, the kind of acronym that's used out there a lot is called SARGs, a search argument. So this is what you want to provide plenty of to the query optimizer, even an overabundance of query of search arguments, to help the optimizer choose the best access methods and the best algorithms to to get to the data that you were requesting. So let's talk about some ways you can help the query optimizer figure out what kind of data to get and how to get it. One thing I like to point out definitely is that there's a little bit of confusion about composite keys. And what I mean here is that, let's say, for example, we have created an index on 4 columns, A, B, C, and D, these columns. And one thing that used to be the case in SQL Server was that the order of the columns that they appeared in was actually important, pre-SQL 2000. Now that's not so much of an issue. You don't have to worry about that in 2005 or 2008, whatever order. You could have this in other orders, for example, when you reference them down here in your web clause. So that used to matter. Now it doesn't matter quite so much. But that's caused a lot of people to think, oh, it doesn't really matter at all, which is not true. So let me demonstrate for you. If I have this index here called index foo, so I have the foo index. If I do a lookup on that table, and I just have a where clause that references the first column here, I'm going to try and use my little highlighter here to mark that, column A. Well, then it actually doesn't need any of the other columns of the index to use that index. If I used column A and column B, it's concatenated, remember, so it builds the index on all 4 of these. It will also go ahead and use that index. But if I go beyond that, I'm going to have some problems, and let me explain. So if I wrote a query that, and I'm showing this here in this example, if I wrote a query that accessed A, column A, and none of the other ones until we got to column D here at the end, it would only be able to use that part of the index that relates to A, because the index is composed of all 4 of these columns, and it actually can't find the data all the way down to this 4th column because we skipped B and C. So once we have skipped out of order, it won't be able to use those. Same thing here for the next one, the next example. If we call for where variable equals column A, and then we skipped a column and went to column C, and also asked, and then we may lose that if we skipped to C. Now here we actually added B back in, and I think it's starting in SQL 2005, it would actually be able to use all 3 parts of this index, A, B, and C, because it would see, aha, I've got you right here. It just wasn't referenced in order. And then finally, what if we actually skipped the first element, the first aspect of the first column here, as we show in this example down at the very bottom? Well, actually it would not be able to use this index at all, because it has to start looking up values based on the value of column A, and that's not present in there, so it cannot use that index at all. So I hope there's some other indexes it might be able to take advantage of. SQL Server 2005 don't have an issue with joins, the order that you put them in. However, every additional join that you add into a SQL Server query adds another layer of kind of I guess you could say, another layer of complexity. It gets more and more complex. So although you are able to join up to 32 tables, and sometimes SQL Server will try to resolve a subquery as a join, then that's going to count towards the total number of joins that SQL Server can do. So if you actually have like a 16-table join, just one column, the SQL Server has to process through like 32 million alternatives. So really, the very, very strongly encouraged to not build queries that have more than a 5-table join. Just don't do it. And don't fool yourself into thinking, well, what I'll do is I'll build 2 subqueries with 5-table joins and one overarching master query that pulls those in and joins to those. It doesn't work that way. You can't shelter queries and joins inside a join, so that if it's in one transaction, it's going to try and resolve it all as one batch. So it's one of those tricky things that you really want to avoid having 5 or more tables in a join. Another thing, too, I'd like to point out is just the idea, again, of giving the optimizer more than enough, an abundance of information. And, one of the things that we were taught way back in the day about algebra is that it's called the transitive property. If A equals B and B equals C, then we know intuitively that A also equals C. If A is a fruit and B is a fruit, and B is actually banana and C is an orange, then A is also an orange, because we know that A and B are equal. So this is the kind of thing that I see overlooked a lot. It's an opportunity that's really easy to add to your SQL code. A lot of people will leave off that third line here. So maybe you're coding something and you say, I've got a 3-table join, and I'm going to join these 3 tables together, and I link the first 2, and I link the next, I link the first 2 to each other, and then I link these 2 to each other, but I don't take the step of linking these 2 to each other right here. I encourage you to go ahead and do that, as I've shown here on this last line. Go ahead and add that last element of the where clause in, or last element of your join clause in, so that you just give the optimizer a little more help and a little more capability to figure out what it can do to build those access methods for that and the execution plan for that query. Another thing to think about is that OR clauses are actually resolved sometimes in SQL Server as if they were unions. You might even consider using a union rather than just going straight for an OR. There are some situations where a union or a union all can be better performing than an OR clause, kind of one of those weird little tricky things that happens from time to time. Like is also a sensitive issue, because it can inject a lot of issues to your SQL Server queries. The bad thing about like is not when you have the wildcard at the end of an indexed value. So like here, if we're looking at last name, and we know we have an index on the last name column, and we have a wildcard after the first letter. Well, actually, the SQL Server will be able to use the index up to that first letter. So it's going to find all the W's really quickly. And then, it's going to do a range scan on all the last names that begin with W. Where SQL Server now has to wrestle with some issues is if you have a leading wildcard here at the very beginning. So we have that percent at the very beginning, and we're looking for Walton and Dalton and things like that. Well, the index is probably not going to be used at all. And so you've got a situation where you can actually hurt yourself by doing it this way. Now, another thing, this is pretty well known, but I want to make sure it's repeated just in case there's anyone out there that is not aware of this, and that is anytime we query on a column's value, SQL Server is going to try to use an index that exists on that column unless we do something tricky to that column. So if we do some math on that column, or if we apply a function call to a column, even though we know that column is indexed, SQL Server can't really figure out what it needs to do to that, because it's got to look at the raw values first. In this case, it's got to look at the quantities. Down here, it's got to look at the dates. And since we're applying functions and multiplication or division or some kind of algebra or something like that to it, it says, oh, you know what, I'm not sure what the original value is because all these, different kinds of acrobatics that are being performed on those values, so I better not use the index on that. So the key thing to remember if you have a situation where you have to do some manipulation to the values to figure out what they are is to move those values onto the other, the comparison operator of the calculation, or I'm sorry, of the search argument. So maybe we want to move it over to this side of the comparison there. All right. So we're getting close to finishing up here. In the old version of SQL Server, there was something called the Database Tuning Wizard. It's now called the Database Tuning Wizard, and it's much better in SQL 2008, 2000. Earlier versions of SQL Server, I would not recommend that you use the Database Tuning Wizard. But with the later releases, you could use Profiler to collect some activity on the SQL Server, and it could tell you what is happening on that SQL Server in terms of indexes, and maybe suggest some decent ways to add an index here or there, something like that. I would treat it kind of like the recommendations of a junior or maybe inexperienced DBA who knows some key rules. So don't just go blindly applying all of them, but the Database Tuning Wizard can be, the Index Tuning Wizard in the old version can be effective at helping in some cases. Oh, and by the way, I think I must have pressed hide on one of the slides here, but there's also several very, very useful DMVs, Dynamic Management Views, inside of SQL Server specifically for indexes. So they can tell you about missing indexes, they can tell you about underused or misused indexes, and things like that. So make sure you look at the various indexes, the various indexing DMVs that exist in SQL Server 2005 and 2008. They are really, really helpful. All right, so let's do a quick review here. Understand that primary key of your table. Is it read? Is the table used for reads? Is it used for read writes? And then from that, you can decide a lot of different things, like how much your fill factor is, how many indexes you want. If it's primarily read, then you will want a lot of indexes. You'll want the fill factor probably at 100. You'll want all of those data pages to be full so that SQL Server doesn't have to read in more data pages to contain the same amount of data. I strongly recommend that you always create a primary key. I also encourage you to add non-clustered indexes to not just foreign keys, but also to other columns that are used for things like joins, that are used for group by statements, and that are used as search arguments in where clauses. Those are great candidates for being indexed. You might want to use the Index Tuning Wizard. If you've never used or done much indexing, you might want to use the Index Tuning Wizard. Or I would recommend even more strongly using the DMVs around index tuning. And most of all, really, don't be afraid to test and analyze and experiment. Really, really good practice to get into. With your queries, avoid requesting more columns than you need. Limit your searches through your, limit the search and through your search arguments. Use covering indexes or even things like indexes with include columns or filtered indexes to get the most out of your indexing rather than going always straight all the way down to the data. Learn about the rules for or and like subqueries or clauses, and how joins and composite keys and whatnot can impact your got a little pop-up there, can impact your the performance of your queries. All right, and then finally, make sure you're aware of everything that's going on with your functions and things like that, calculations. Those can really inhibit the behavior of the different indexes that you have on the queries. Just a few things to wrap up. I do work for Quest. We've got a lot. I'm kind of proud of this new poster that we just did on perfmon counter. So if you've never worked much with or you think you should and you haven't done it yet, I encourage you to take a look at that free poster. We'll send to you anywhere in North America. We've got a few others at that same URL there. And also this DVD, training DVD I did with Ari Weil and Brent Ozar and Buck Woody from Microsoft. You can get that free DVD training that we all did. We always have a lot of fun, and it's good information. And that URL is down here if you want that for free as well. You can get that online. A couple Quest resources there, which I don't want to bother you with. And then for follow-up and questions, you can follow me on Twitter. I blog all over the place. It's syndicated in a few other places, but primarily at kevineklein.com. You can get slides for lots of my different sessions and webcasts and so forth there. And also I'll answer any questions you send to me after the fact as well. I'm not sure if we have any time left, but I did want to turn it over to Tim at this point. And Mr. Mulick, how are we doing for time? Do we have time for
we're doing great. And if you don't have to run, I know everybody will hang around. We've had quite a bit of attendance this morning and this afternoon. I'm used to the morning. Once the audio was fixed, Kevin, it came out great. So a number of questions from a number of you may be new to this whole scene. We record this session entirely, and it will be up on our website by either the end of today or certainly early tomorrow under Pragmatic Works under webinars. And all the free webinars we do every month are there for those of you that are new to us. And Kevin, a lot of times I get requests for the PowerPoints. Are your PowerPoints proprietary? Are they ones that you would share that we could have people download?
Oh, absolutely. Yes. And I think there's an old version of this slide deck already at kevineklein.com/slides. But Tim, would you like me to send you the newest, and then you could post it on your site, or how?
That'd be great. That'd be great. That way, folks can get it either way, whether they go to Kevin Klein or they go to the webinar, and you can download it at the same time as you're reviewing the recording. So that's there. And we have a bunch of questions. Are you ready, Kevin? I'll read a few off to you. All right.
I am ready.
This one goes out to Dexter. Dexter's been waiting for a while here. Where is index data physically stored? Is it leaf pages?
Yes, there are leaf pages. So what happens is SQL Server basically creates an object that is associated with the table. And so, there's not, I'm trying to figure, it's kind of like triggers as well. These are objects that are associated, they exist independently inside the database, but they actually, are linked so strongly to the object itself that, they're not typically something you would just find independently of the table. Now, if you're using SQL 2005 and later, you can do queries against the DMVs to see exactly a great deal of information about those, about the indexes. And there's also a command, not typically used real quickly, the command is called dvcc page. And you can actually use that to look at the physical pages that are written for an index. And so that will be another way that you can actually look at that data if you want to. You can use it to look at both data and index pages, but it's a neat, kind of not well-known command if you want to look at data inside of an index.
Great. Okay. This one goes out to Ashish. Ashish Kale, how does one decide what fill factor number to use, like 50%, 70%, 80%?
Well, if you don't have any experience, and that's a great question, if you don't have any experience with fill factor, the kind of rule of thumb for an OLTP system that has lots of transactions flying around is probably somewhere between 70 or 80. So, just according to, and it's an experimentation sort of thing. So many people will use 70 or 75 or 80 just because that's worked well for them in the past. But it's not necessarily, going to be guaranteed great or better performance, but it's a pretty good guess. The key thing to remember with fill factor, too, is that you have to reestablish it occasionally. So if you don't have a scheme, a maintenance plan or, some job set up to rebuild the indexes on regular intervals, then your fill, you could have set a fill factor of 70%, and it fills up, the empty space fills up over time. So you do need to rerun that. But if you have a OLTP system with transactions, I would recommend starting at probably, my rule of thumb is 75, and adjusting those as evidence might indicate otherwise. Now, if you have a, whoops, I wonder what happened there. If you have a transaction process, I'm sorry, not a transaction processing system, but a BI system, one that does lots of reads, or a reporting system, then you probably want to set that fill factor up to 100 so that you'll have fewer data pages to read.
Okay, great. Thanks, Kevin. Ashish had another follow-up to that question, which I think would be important here for everyone. How does one know that too many page splits have occurred?
That's an easy one. There's actually a perfmon counter for that, as well as some DMVs that can tell you what's going on with the number of reads and writes and so forth that are happening. So you can actually find it on my website. On my blog, I have a blog entry about favorite DMV queries. And so what you can do is there's a DMV called DMOS performance counters. And so you can look specifically for the performance counter on page splits. There's another performance counter specifically for forwarded records, which I mentioned earlier in the presentation. And so you can look specifically for those things. And if you have a number, even I would say in the low double digits, like if you have 20 or 30 of those popping up on a regular basis, then that's a pretty good number. So, I would start to pay attention and try and deduce where those page splits are happening and whatnot, and fix that.
Okay. This one goes out to Pete. This is regarding indexing. Should I be using an index on staging tables for an ETL?
Well, usually, and that's a great question, Pete. Usually, most people do not index their staging tables and whatnot. As I had mentioned early on, Heaps are really effective at loading large amounts of data quickly. If you're using bulk insert, or maybe you're using BCP or the SSIS jobs for doing big runs of data, I would say most folks actually do not build indexes or do indexing at the loading phase. They only do it after staging, once it actually goes out into into use.
All right, we'll go into partition table here. This one's for Shahara. For partition table, you can't create a unique index without adding the partitioning column to the index. How can you create a unique index on just one column for FK relationship on a partition table?
For a foreign key relationship on a partition table?
Yeah.
I'm not too sure off the top of my head. That probably is a question for one of the Microsoft forums or support or something like that. And I would even back up a little bit and say, why do we need to have just one column? There are some people, of course, who love to have a single column as a key. I'm not really in that camp. I feel like it should be dictated by the business needs. So if you need to do partitioning, and you have a unique index already out there, it sounds like you're going to need a concatenated key to me. But again, there is probably a way to do it, and I wouldn't be surprised if one of the very smart attendees of our session knows how to do that already. But off the top of my head, I don't.
All right. Here's a question here. It goes into the Oracle world a little bit, so let's see. Let me know if it's not necessarily your world, Kev. Is a clustered index the same as an Oracle index organized table? That is, does the leaf node of a clustered index contain the actual data you are looking for?
The good news there is that, yes, an IoT on Oracle is pretty much identical to a clustered index on SQL Server. The only difference is one of emphasis. So whereas in Oracle you can be perfectly happy and get good performance without an IoT, in SQL Server it's really, really strongly recommended. So, and it has a little bit to do with the fact that SQL Server only supports one structure right now for indexing. So it supports a binary tree index structure, a B tree, whereas Oracle allows you to have a couple to choose from. So yes, they are the same thing. They act in pretty much the same way. However, in Oracle, the recommendation to have IoTs is not as critical as it is over here on the SQL Server side.
All right. Thanks, Kevin. I knew that would be, I wasn't sure on the Oracle side, but of course you got a lot of Oracle expertise, so I thought it might be one you could answer. This one's for Christian. I know we're over the top of the hour here, but do you have time for a couple more questions, Kev? If we,
I do, yeah.
all right, excellent. All right. Yeah, we've got a lot of people that have written some great ones here. Christian, if all columns in your select statement are not covered by an index, how much of a performance hit do you take?
If all columns are not covered by
No, I'm sorry. If all columns in your select statement are not covered by an index, how much of a performance hit do you take? Here, he goes on here a little bit. I'll read it off. You'll have to use bookmarks to return the missing column, correct? Or bookmark lookups are expensive, right? How do you weigh the overhead of a covering index to include some little used columns against not having them included? How would you gauge that?
Gotcha. Okay, so actually what you're doing, Christian, is you're kind of mixing metaphors there. So yes, it is true that bookmark lookups are expensive, but that doesn't mean that every column that's not covered by an index will have to be found through a bookmark lookup. So bookmark lookups are actually an access method that are used in certain special cases, and I would say for most people's normal queries, they don't turn up real often. And in fact, they are a red flag. Usually, if you're looking at an execution plan for a query, and you see you have, many bookmark lookups, then it's probably a good, good opportunity to tune it. So the access methods that SQL Server will use are things called seeks. Hopefully, you'll see either seeks or scans. That's the logical operation. The physical operation might be something like, for gosh, I don't know, let's say on a join condition, it might be something like a nested loop algorithm using a left semi-join, something like that, or an anti-join. So I'm giving a little more detail than probably I should, but you're not necessarily going to take any hit at all, because a SQL Server can find a useful index, which means you'll see in the execution plan that it has performed either a seek. Usually it's going to be a clustered index seek, or maybe a non-clustered index seek of some kind. That means it's actually got a laser sight on the records and the data it needs, and it's going to be performing very quickly.
Okay, great. This one goes out to Brandy. Brandy had a few questions for you. Let's see here. How does one know when to add columns to a composite clustered index versus adding them as included columns to the clustered index?
Yeah, great question. The key differentiator between when you should have a composite index as opposed to a included columns in a regular index, the big difference is whether you need that column for selectivity or not. So let's say, for example, I'm trying to think of an example that actually makes sense. Let's say, for example, we've got some reports. Maybe let's say you run a school and you're going to print off diplomas to everybody who graduates, but we don't actually do any reporting, we don't do any sorting, we don't do any grouping by middle name. So in that case, well, it wouldn't be a good use for a covering index, actually, because we don't use the middle name to help locate those records in the database. But we do frequently call for middle name if we've asked for the first and last name when we do the certain operation for printing out all the diplomas and whatnot. So we might include the middle name column in that index rather than create it as a composite column or a composite key. We might include it just so that it has that data right there whenever we do a lookup on the index. So that's the big difference typically.
Okay, all right. Thanks again, Kevin. We have Javid here. Can you expand on how to determine if I should make a composite key or add it as include? What are the best practices?
Well, and that's exactly what Brandy just asked.
Yeah.
It's
oh, sorry, did I blow that one?
How does it utilize that data? Is it actually using it to locate the record that you need, or is it actually just something that is used frequently? If it doesn't help locate the record, then you don't need to add it to the index.
All right, great. All right, let's see here. We'll go down to Brian. Brian's been waiting for a while. Let's see here. Question on query best practice, number 6. Does coalesce function on where column also cause index to be ignored? Are there any functions that don't cause the index to be ignored? Does that make sense?
Actually, yeah, it does. It does. That's a great question, actually, Brian. There are quite a few columns that, functions that don't ignore a index. For example, and I feel bad too because the example I wrote earlier in the slide deck is the isNull function, and that actually would invalidate an index up through SQL 2000, but now in 2005 and 2008 it doesn't. So I actually didn't. I've been too lazy to correct that old example there. So things that deal with null would be isNull, the NVL function. Coalesce is another one that doesn't actually invalidate indexes. So there's a short list of those, and you'd have to go to books online to actually get a full list of what those are. But yes, there are some functions that don't tamper with the clustered index. With index utilization, I should say. And coalesce actually is worth a little bit of a side discussion too, because coalesce is quite useful for tinkering with a query to ensure you get the same result set, but it actually will change the execution plan. So sometimes I've actually used a query, I've written a query and just added a coalesce on one of the where clause conditions, just to force SQL Server to come up with a different execution plan, sometimes just to compare the behavior of two different queries just to make sure it's taking the best possible route it can to get to that data.
Great. Okay. Sorry about that, Kev, asking the same question twice. I do have a simple question for you. Can you post the PowerPoint with the links to all the posters? I see you have the posters here, but I'm not sure if that was the same one. Everybody's asking for it here in the chat.
Yeah. So the URL at the top is for all the posters, and the URL at the bottom that says free DVD training. Can you see that, Tim?
Yeah, I can see that. So I mean, that I wasn't sure because you had a slide prior to that kind of maybe it was through animation. Right. Okay. Yep. So that's how you can get all the posters, folks. We have a lot of questions about that. We have time for one more question here. This one's for Andy. Does using an identity field as an index change? Does that change the fill factor? Does that make sense?
Oh, no. Yeah,
okay.
No, it doesn't. The identity, basically, the identity field is established usually on like an integer or a big int data type column, and so that has no impact on the fill factor. To go on a little bit further, some people will caution you about identity fields because sometimes they can cause page splits, or actually they don't cause page splits. They're actually good because they cause what's called a hot page, so that all the writes happen at the very end of the data file. So there's a lot of discussion about identity fields and their usefulness in, particularly in things like a unique index or a primary key or something like that. And so basically, identity fields can have some benefit for heavy write systems that have a lot of kind of randomized writes in terms of inserts. Because if you establish your primary key on an identity field, then that means every new write that comes along, inserting a new record, will do it at the very end of the data page. At the very end of the table, rather than kind of mixing those in across lots of different pages. And that means that if you had only one hard disk, let's say, then the hard disk armature and the head, the read-write head, wouldn't have to move around a lot. It'd all be sitting kind of the very last record entry, writing new entries according to the clustered index rule of the identity field. New entries at the bottom of the data page. So there are some recommendations out there floating around that an identity can be really good for a primary key on a table that has lots of inserts like that. I'm a little bit less vigorous in my endorsement of that. It is a good idea, but you really need to know the data structure and the way the application works and so forth to take advantage of that. So it can be useful, but it's not an impediment at all to fill factor, which kind of your
All right, great. Well, we're just about 11 minutes after the hour, so it's been quite a bit, and I want to make sure we have space for the recording this afternoon. Kevin, is there anything else you'd like to add before we wrap up?
Oh, just thanks for the opportunity, Tim. It was really fun, and I'd love to come back and do it again sometime.
Yeah, it would be fantastic, Kevin. We enjoy having you. I do want to ask everybody, of course you can't answer, but if you're going to PASS, Kevin, will you be at PASS this year?
Oh, well, thanks for pointing that out. Yes,
Yeah.
I will be at PASS this year. And so if you're there, come by, say hi. I'll be in all kinds of different places. I'm presenting one session, but, I'll be in the Ask the Experts area. I'll be in the at the Quest booth. And I'll probably be having a beer with Tim at some point. So, yeah, come by and say hi. Definitely love to catch up with you.
Yeah, and please come by and see us as well. Pragmatic Works will be there. I think we're right next to Quest. Quest has the huge booth, and we have the little booth. But, they've been in business for 15 years, so they can do that. There were a lot of questions about where to get the recording, so I will just flip screen and end the webinar, but I'll leave this page up a little bit just to show you. We are actually, if you go, hopefully you can see my screen, and this is pragmaticworks.com. Just go to webinars, and we will have the webinar up along with all the other webinars that we've done in the past and in the future on this page here. So you just have to go to this page, and what we'll do with Kevin is you'll see view recording. It's not posted yet, but as soon as it is, you just hit view recording, and Kevin's nice enough to share his slides. As soon as we get that, we'll put the slides up here as well, or you can go to Kevin's page and get the slides also. So either way, we got you covered. And with that, I'll go ahead and wrap it up. Thank you, everybody, for coming, and we hope to see you Thursday, and we'll talk then. Thank you again.
Thanks.
Thank you, Kevin. Bye-bye now.